I want to do two more examples of logarithmic differentiation. So I want to show that this first one is f of x equals x to the 6th sine x. And since we have this more complicated function as our exponent on x, then that makes us want to use the logarithmic differentiation method. So we'll take the ln of both sides. And because of the log rules, we know that because we have an ln of this function, that means I can bring this function in front because of the log rules that allow the power to become a multiplication problem. So we'll rewrite that right-hand side, 6 sine x times the ln of x. And the nice thing about this is it creates a situation where I now have a product. This would be my first. This would be my second part of the product, and I can use the product rule to get the differentiation of the right-hand side. But on the left, we do have the ln of f of x, and f of x is a function in terms of x, or essentially a y. So when I do the derivative of the left side, I get any derivative of an ln is 1 over that function. And since this is a function with respect to x, then I've got to do times the derivative of that function, using implicit. The right-hand side will use the product rule, so I have first times the derivative of the second plus the second times the derivative of the first remembering that the derivative of ln of x is 1 over x, and the derivative of 6 sine x would be 6 cosine x. So I have the derivative taken on the left and on the right, but we want to solve for f prime of x. So I do need to take care of this part of on the left side. And if we multiply both sides by f of x, then we'll be able to isolate the f prime of x. And I'm going to show that first of all just by multiplying both sides by f of x. And we'll put all of our derivative in here just to kind of keep it separate for the time being. And I can simplify that, combining those first two parts, if I want to. And this is fine just as it is. Now you could leave the answer this way, but it really would be a better answer to put everything in terms of x and not have this f of x here as part of the answer. So I'm going to go back and look at what f of x was defined to be, and in the very first part of the problem we defined f of x to be x to the 6th sine x. So let's write that in now as our answer for f of x. So that would be x to the 6th sine x times all of our derivative pieces here. And that would be the answer for the logarithmic differentiation for f of x equals x to the 6th sine x. Let's go ahead and do one more example. Our second example will be y equals cosine of 9x, all of that raised to the x power. And again, because I've got the complicated function of having a function of x raised to another function of x, then the natural log on both sides does help me to get it into a better format. So that would be cosine of 9x to the x, and just like before, we'll bring down the x. And the left side differentiation will be 1 over y. And this is an implicit differentiation since we're getting the derivative with respect to x, but this is a function of y, or a function y. And so I'll take the derivative of the 1 over y, or the y. And then on this side again I have a product, or I have two parts. So the first times the derivative of the second. The derivative of the second for this ln function is going to be 1 over exactly what's there times the derivative of what's inside, and the derivative of cosine is negative sine. But then that's also a chain rule piece because I had the sine x of 9x, so I need to multiply all of this times 9. So the 1 over cosine was the derivative of the ln. The negative sine 9x was the derivative of cosine, and 9 was the derivative of the 9x. So that's the first here, derivative of the second, plus the second. Let me make that ln. Second times the derivative of the first, and our first was just an x, so we've just got derivative of 1. I'm going to simplify just a little bit so I can keep up with all the parts of my answer. So I've got 1 over y times y prime. I'm going to combine all of that on the top, which would be negative x sine 9x, just getting some pieces together. Left off the 9, so we can put it back here. It could have also gone in the front, plus ln of the cosine of 9x. Multiplying everything by y, and because I'm going to go back and use the y that's in the beginning, I'll put the y in. I'll move that 9 up here now. And one last line. In place of the y, we're going to go back to what our original function said y was equal to, and y was the cosine of 9x to the x, and then everything in the parentheses, which I forgot to close out. Negative 9x sine of 9x over cosine of 9x plus the natural log of the cosine of 9x. And I have finished taking the derivative of the function y equals cosine of 9x to the x.